ready for takeoff.
Hello, everybody. Welcome to Improving the Development Experience with Language Servers. I'm Vinny. I'm a part of the Ruby Developer Experience team at Shopify. We do a lot of work with developer tools, all of them somehow connected to the editor. So we're involved with gradual typing using Sorbet and Tapioca. We recently started doing some contributions to Ruby Debug, which is a debugger that can connect to your editor for interactive debugging through the UI. And I'm going to tell you a little bit more today about the Ruby LSP, which is another editor tool that we're working on. And if you want to know what I'm up to, you can find me at Vinicius Stock. So to understand language servers, we first got to take a look back at how language features were added to editors before they existed, so that we can appreciate the problem that they were trying to solve. And by language features, I mean stuff like formatting, go to definition, autocomplete, that type of thing. So imagine you were a Vim user and you wanted to get those language features for Ruby inside of Vim. Well, in order to do that, you would need a Ruby plugin implementing those features for Vim. And if you also used JavaScript, say like in a Rails application, and wanted to get specialized features for JavaScript, you would need a JavaScript plugin implementing those features. And the same thing for any other programming language that you wanted to get specialized features delivered in the editor. And this separation is great because you get to pick and choose only the support for the languages that you work with. But then imagine somebody else used a different editor like Sublime, and they also wanted to get specialized Ruby features inside of Sublime. Unfortunately, they would not be able to reuse all of the features that had already been implemented for Vim. And there are a few reasons for that, but mainly because plugins made for different editors are not made using the same programming language. So for example, VS Code uses JavaScript and Vim uses VimScript. But even more impactful than that, the internal design of the editors can be completely different, the way they handle buffers and files and windows. And so the API they end up exposing to their plugin ecosystem can also be completely different. So there's really no hope of taking a plugin made for one editor and just sharing it as is with a different one. So you would need to recreate that Ruby plugin and re-implement all of those features, and the same thing for all of the other programming languages. And if we add as many programming languages or editors here, the scenario, the story repeats, is always the same. This meant that we couldn't come together as like a community, like the Ruby community, and collaborate in making the developer experience better for everybody, because your developer experience was tightly coupled with which editor you used. In addition to that, there was no standard set of features that you could expect from a language plugin. There's no guidance as to what it meant to implement language plugins. So if you compared like Ruby in Vim and Ruby in VS Code, you could get a completely different set of features present in your editor. And the difference could be even larger if you compared across programming languages. So you could have a very rich experience for JavaScript in VS Code, but an incomplete experience for Go in Sublime or something like that. And so what ended up happening is that you actually didn't have one Ruby plugin for each editor. You ended up having a most popular Ruby plugin, and then smaller plugins would emerge around it to implement slightly different or specialized functionality, like better syntax highlighting, or go to definition, or linting. And this fragmentation is not a great experience because it means you can't install a single plugin and get everything you want, batteries included, to work with Ruby. You actually need to install a combination of plugins and make sure they're configured the right way so that they don't conflict. To tackle this problem, the Language Server Protocol, or LSP for short, was proposed. And the idea is that it's a specification on how to write a background server, so a process continuously running on the developer machine that can communicate to any editor via JSON. And in addition to how to write the background server, it also provides us with this list of features that you can expect from any language server, no matter which programming language it is implemented for. So the idea here is that the editor is the client, kind of like the browser in a web application, and our backend is the language server, the process continuously running in the developer machine. And they communicate with each other through standard in, standard error, and standard out by using JSON. So for example, if you were to go to the definition of a method in the editor knows how to translate that action into a JSON request, which is sent to the server. The server figures out where the definition of that method is, returns the response as JSON to the editor, and the editor then knows how to translate the JSON response into whatever behavior needs to occur, which in the case of go to definition would be to jump to the right file at the right position where that definition is located. So after language servers, our story here changes a little bit. The editors can now implement a client layer that knows how to do those JSON translations from actions to requests and from responses into behavior. And that client can then connect to a Ruby language server that implements all of the Ruby specific features. And all of the other editors can then implement their own client layer, which knows all of the editor-specific design and can do all of those translations, but they can all connect to the same language server providing those features. So you decouple the editor-specific parts from the programming language-specific parts. All of the editor parts are in the client layer, and all of the features are implemented in the language server, so we can all collaborate on improving the experience. And because the clients only deal with JSON, they can connect to any language server. It doesn't matter for which programming language they were made. They all communicate with JSON, so you can connect to any of them. As a reference, this is what a request in the LSP looks like. You have an ID, which is an incremental number identifying this request, and it is used for the server to inform the editor which request you are responding to, because your server may be multi-threaded, so there's no guarantee that the responses are going to be sequential. The method is the feature that you're trying to compute, and I like to think of that kind of like a route in a web application. You're making a request to this route, and then the set of parameters of that request, which in this case only includes the URI of the text document. Another form of communication available to LSPs are notifications, and the only difference between a request and a notification is that the notification doesn't have an ID because it doesn't expect a response back. So this is the editor notifying the server that something has happened, or vice versa, the server notifying the editor, but there's no response involved. So in this particular example, the text document did open is a notification sent from the editor to the server when a file has been opened in the UI, and the parameters are the URI of that document and the current content of the document. If we were to take a look at a sequence of interactions between the editor and the language server, it would look like this. Once you open your editor in a Ruby workspace, the first thing is activating the language server. And to do that, the editor sends an initialize request to the server. What it expects back as a response is the set of features that your server currently implements. So you don't have to implement the entire specification in one go. You can implement it gradually, and your server has the opportunity to broadcast to editors what you currently support so that you only receive requests for those features. And that's commonly referred to as the capabilities of the server. Once it's been activated, then we can start with like regular coding operations like opening a file. If we open a file, the editor is going to notify the server that that file has been opened, and it is the responsibility of the server to maintain an internal representation of that document. It needs to know that for that URI, for that file path in the system, there exists a file, and it needs to know the contents of that file at all times. And this process is known as text synchronization. We need to keep the text synchronized from the editor into the server state. Right after we receive that notification, then the editor is going to want to compute features for that file you just opened so that they're available for you. So you get a wave of language feature requests, such as folding range, one after the other, and the server has to respond to that. And to close our example here, if we were to edit the foo.rb file and add a method definition, then the editor would notify the server that the contents of that document have changed, to give it a chance to update its internal representation. And because the contents have changed, then the features, the results of the language features may have also changed. So we get another wave of language feature requests, one after the other, and the server has to recompute those. The Ruby LSP is a new language server that we're working on for Ruby. There are two repos here on the slide. One is VS Code Ruby LSP. That one's the VS Code extension that connects to the server. And the other one, Ruby LSP, is the server gem. But I want to stress out the fact that the Ruby LSP gem can connect to any editor that supports the protocol. It doesn't have to be VS Code. And also, the server is entirely made with Ruby. So if you want to follow along with the examples that I'm going to show now, you can just open the repo and follow along. But what does the Ruby LSP currently do? So a few of the features we currently support are folding ranges. So these are the little icons there on the gutter of the editor to allow you to collapse or expand code. Document highlight, so when you click on a Ruby entity, it highlights the other occurrences of that entity, in this case, the name instance variable. RubyConf diagnostics, so if you make a violation, it will surface that in the editor, and it also supports quick fixes through code action, so you can fix that directly in the UI. We have hover for displaying documentation links for Rails DSL methods, so like has one, if you hover over that, it will pop up the link to the online documentation. If you click it, it just takes you to the website. We have a few inlay hints, so like for example, if you rescue without specifying a specific error class, the default implicit behavior is to rescue from a standard error, and so the Ruby LSP will tell you that with an inlay hint. We have auto formatting, so if you save the file, it formats on save and fixes your violations. And finally, the last example is format on type. So in this case, we're adding an if statement. When you break the line, it automatically closes the end token for you. So let's see how it actually works and how we implement these types of features in Ruby. As a reference of the overall architecture of an LSP, it is an infinite loop that keeps reading JSON requests from the standard in pipe. And then based on that method attribute, which is the feature that we're trying to compute, we have to decide what to do. So depending on which type of request you got, you need to define what it means to execute that request. We need to run that request. And then after we have a result, we have to write that result as JSON into the standard out pipe, which returns that to the editor so that it can serve the features. Like any language server, the Ruby LSP has a few different responsibilities that it needs to account for. I just want to call attention to what we're going to be taking a look at. So it does text synchronization, as mentioned in the previous example. It needs to parse Ruby files. It implements positional requests where the cursor position matters. So like hover, you need to serve the request based exactly on where you're hovering in the file. And it also implements non-positional requests, which are features that are computed for the entire file at once. And we're going to be focusing on those, the non-positional requests. More specifically, we're going to be focusing on folding range. So again, these are the little icons next to the line numbers that allow you to expand or collapse code. And this feature is computed once for the entire file. So you find everywhere you want to fold your code once, and you return that to the editor, and then the editor populates those icons for you. So how do we implement something like folding range? As a reminder, this is what the request looks like. We get the folding range method, and the only parameter we get is the URI of the document. So by the time we receive this request, the server already needs to have an internal representation of that document, because you don't get the text content of it. So it needs to already know what is the content of that file. And what the editor expects back is a list of ranges, and the bare minimum to compose a range is the start line, the end line of the range, and the kind, which can be region for generic parts of the code, comment, or imports, which in case of Ruby would be more like requires. So if you take this post class here, we can visually inspect it And we would probably realize that we want to be able to fold it in the method definition and in the class definition. But when we're synchronizing texts from the editor into the server, we're only dealing with raw text. It's just a string with all of your Ruby code inside. And that's very difficult to analyze. So we got to be able to go from the raw Ruby code into something that has a little bit more information for us. We want to be able to assert what are the Ruby structures and entities present in that string of Ruby code. So for that, we're going to be parsing the file into an abstract syntax tree so that we actually have an object that describes everything that's present in the file. And then the last step in analyzing and implementing these requests is to go through everything that is defined in the file, so traverse the AST, and then perform some analysis. In the case of folding range, we're going to be collecting the ranges where we want to be able to fold the code. So what is parsing? Unfortunately, I don't have enough time to go into a lot of detail into what is parsing. If you were at RubyConf Mini a couple of weeks back, Kevin Newton gave a great talk on syntax tree, which is the gem that the Ruby LSP is based on, and explained parsing in a little bit more detail than I will go into. But in very basic terms, parsing is the process to go from the raw string of Ruby code into an object that describes that file in terms of the Ruby structures that are present in it. So it's a kind of like a linked list tree structure that describes everything that's present in that file. So we have, in this case, in our post class, we have a class node as the entry point of our AST with two child nodes, the post constant and the body of the class. Inside of that body, we only have a method definition with two child nodes, the title identifier and the body of the method. And finally, inside of it, we only have the string RubyConf. So we want to be able to take that AST, take that object representation, go through everything that is defined in our file, and then identify the places in which we want to be able to fold the code. So we want to be able to find the class definition and the method definition node. Which means we need a way in which we can take that AST and go through everything that is defined in it, study all of the Ruby structures present in the file, so that we can collect information about the folding ranges we want to be able to return to the editor. And there are multiple ways in which you can traverse an AST and go through everything that is defined, but we're going to take a look at how syntax tree allows you to do it out of the box, which is how the Ruby LSP does it by using the visitor pattern. If we were to implement it, we would begin with a parent class visitor for which all of our non-positional requests will inherit from. And the entry point of our analysis is the visit method, which receives any type of node that can be present in our Ruby file. So it could be class definition, a method definition, string, it doesn't matter. And we invoke accept on it, passing to it the current instance of the visitor. In order for this to work, every single type of node has to implement the accept method, and the implementation is analogous to each one of them. You take the visitor and you invoke a specific visit for that node type on the visitor. So in this case, we have a class node. We're going to be invoking visit class. If it was a constant node, we would be invoking visit const. The idea is that instead of having a big case statement where you do when it's a class node, do something. If it's a method definition node, do something else. The idea is that the visitor asks the node, hey, I don't know which node type you are. Can you invoke the right method on me that knows how to process your node type? That's basically the whole idea of the double dispatch pattern here. And to finalize our implementation, to make sure that we can actually go through all of the nodes that are present in the tree, we just need to define what the default behavior is for those node-specific visits. And they all default to the same thing, which is taking each one of the child nodes for that particular node we're processing and then visiting each single one of them. And it may not be clear why this allows us to go through the AST, so I have a bit of a visualization here. On the right, we have our post classes AST, and on the left, the visitor code that is currently being executed. So we would begin visiting from the top, the entry point of our AST, the class node. Visiting it invokes accept on it, which then triggers the specific visit class method back on the visitor. And that defaults to just visiting all of the child nodes, so that moves us to visiting the const node, which then invokes accept on that node, triggering visit const back on the visitor, which again defaults to visiting all of the child nodes. But const doesn't actually have any child node, so we're actually done with that side of the tree, and we can move on to the next child of the class node, the body node. And then again, we invoke accept on it, which triggers the visit body method in the visitor, which defaults to going to the child node, so it moves us to the method definition node, and we continue doing this until we have exhausted the entire AST and been through every single node, every single Ruby structure present in our file. So the idea here is that you can, with this pattern, you can separate the traversal logic from the actual request logic, and it's going to be a little bit clearer when we get down to implementing folding range. But it's kind of like in enumerable, how you don't care about how each is implemented, you just care about the specific logic of the block that you're passing to each. And with the visitor, we are ready to implement folding range. To do it, we're going to be subclassing the visitor so that we get all of that visiting behavior from the parent. And we're going to initialize it with the AST for the current file and a list of ranges where we're going to be accumulating our results. So we're going to be going through the Ruby structures and accumulating information in that array. Running the request means visiting the AST, so going through everything that is defined in the Ruby file, and then returning the list of ranges that we found along the way. And the last step in order to implement the folding range request is we need to be able to associate logic to when we find a specific node type. We want to be able to fold the class definitions and the method definitions. And for that, we can override those node-specific visits in the request implementation. So we know that this method is only invoked when we find a class node. And so that's one of the nodes we're interested in folding. We can take the location information for that node, where it is defined in the file, and push a new range for that class definition. Notice that if we were to stop right here, every time we found a class node while going through the Ruby file, we would immediately stop our analysis because we're overriding the default behavior from the parent, which was to go through every child node and visit them. But we can easily get that back by invoking super. And I really like the flexibility that this pattern gives us because we can decide if we want to go through the child nodes first or process the current class definition first. We can also decide to stop the analysis if we find a certain type of node with a certain type of content. So I really like the flexibility of the visitor pattern in this case. And finally, to implement the method definition folding, it's completely identical with the only caveat that you need to override the method that is related to method definition nodes. So we override visit def, but the body of the implementation is just the same. We just take the location of that node in the file and push a new range for it. And that already allows us to completely fold our post class here, which was our example that we were trying to implement. The way all of these non-positional requests work in the Ruby LSP is the same. While you're typing, we are synchronizing your text edits from the editor into the server. And once you stop, like once the debounce runs off on your typing, then we parse that file and pass along the AST to every single non-positional request. And they're all implemented with visitors. So basically, they all subclass the visitor parent class, and they just override the node-specific visits for whatever they're interested in. So they're all very similar in their implementation. I want to invite everyone to try out the Ruby LSP. Provide us with feedback, and if you want to contribute to it, again, it is pure Ruby, and I'm happy to take a look with you if you're interested in taking a stab at contributing. The features we currently support are here on the screen, so we support format on save, format on type, document highlight, which is highlighting occurrences for the same entity where the cursor is, hover, Rubocop diagnostics, quick fixes through code actions, selection ranges, which is also known as smart ranges. It's basically expanding and reducing a selection based on the Ruby code. Semantic highlighting, which is highlighting your file consistently according to Ruby's understanding of it. We have inlay hint, document link. Document link is attaching links to specific pieces of syntax, so you can jump to documentation or jump to another file. Folding range, which we've seen and implemented, and document symbol, which allows you to fuzzy search Ruby entities in the file. So if you want to find a class definition or a method definition, you can fuzzy search that in the file. I'm very excited about the future of Ruby tooling. We can have all of those features that I mentioned, plus a lot more, because we're not done implementing the entire specification. We can have interactive debugging directly in the editor's UI, thanks to the debugger adapter protocol, which is the LSP equivalent for debuggers to connect to any editor. We can do gradual typing for more accurate features like go to definition and autocomplete with complete type checking so that it's actually more accurate than without types. And it can all work cross-editor thanks to the LSP specification and the DAP. Or in other words, there is a future in which any editor can be a fully featured Ruby IDE, and we can collaborate getting there. Thank you very much. You can connect with any editor that supports the protocol. Oh, sorry, yes. The question was if there's only a client for VS Code. You can connect with any editor that supports the protocol. So I know some people from the community configured NeoVim to connect to it. The reason VS Code, there's a VS Code extension for it, is because you actually need one for VS Code. It doesn't have like a built-in LSP thing that you can just configure, but you should be able to use it with Vim, NeoVim, whatever other editor that supports the protocol. Right. So the question was if you could use Ruby LSP and Solargraph together. Yes, you can. The way the language server works is it merges responses. So if you have the same response coming from different language servers, the editor will merge them. And in fact, at Shopify, we use the Ruby LSP with Sorbet, which is also provides you with an LSP. So if you have conflicting responses, they're just going to be merged in the editor. Right. So the question is if the LSP supports being connected to a REPL environment with what's actually executing your code. I don't think the specification has anything that is like that explicitly tells you about that support, but I'm sure you can like try to implement something like that to provide the auto completion. Although I do feel like you would face a few challenges in trying to get that especially for large projects, it might be a little bit slow. I'm not sure, but that's an interesting thing we can explore. Right, so the question was if format on save is powered by RubyConf. We actually support two formatters. RubyConf, if you have that in your application, is going to be the default. So yes, it does hook into RubyConf and formats using it. And if you don't use RubyConf, then it will fall back to syntax tree, which actually has a formatter built in as well. So why do we choose a shadow environment instead of RB environment? Well, basically, shadow environment is our in-house Ruby version manager, so we supported that first. But actually, a member of the community made a pull request and implemented support for RB environment, so that should be working already. And there's also support for CHRuby and RVM. Right, so the question is if the client owns the process that's running the server and how many server processes are spawned. Yes, it does own it, so the plugin, the editor, will spawn the process and then keep a handle for the standard in pipe and the standard out pipe so that it can communicate. But it only spawns one server for your like coding session. So the moment you open in a Ruby workspace, it will spawn the server, and it will reuse the same server for all files, for everything that you do until you switch workspaces or close the editor or something like that. So the question is if we could integrate something like a third thing, not only the server and the editor, to provide error highlight or any other features into the editor. I think it is possible. It's kind of the same thing that we do with RubyConf. which is an external tool to the Ruby LSP, it should be possible to do that type of thing. Okay, if there are no more questions, if you have any other questions and you want to just find me, I'm here until the end of the conference. Come chat. I'm happy to talk about developer experience. Also, I did order stickers for the Ruby LSP, but they haven't arrived yet. So come see me if you want a sticker. Once they arrive, I should be able to provide you with one. And thanks again.